The fundamental theorem of calculus is the theorem that relates derivatives to integrals. And there's two parts to it. And really, it's not two different parts, it's just two different ways of describing the same thing. Now, we've already seen the first part of the fundamental theorem of calculus, and it plays out in the process you use to integrate something. So let's say we want to integrate from a to b some function. And you know that when you integrate a function, you're going to end up with the function it came from, or f of x, the derivative of big F of x is equal to little f of x. So we know that when we integrate this, our process would look something like this. We're going to end up with some other function. And we're going to substitute into that function first the upper limit of integration and then the lower limit of integration to evaluate. Right? So it's these two things that make up that relationship, that make up the first part of the fundamental theorem of calculus. And how that will play out a lot of times is you'll be told that f of 4 is 16. What is f of 2? And you're told something about, there's a function f of x, and its derivative is f prime of x, is little f of x, and f of x is equal to, let's just say, 2x. Right. And so the relationship really is that the integral from 2 to 4 of 2x dx has to be equal to f of 4 minus f of 2. Which means, if we solve for f of 2, that f of 2 must be equal to f of 4 minus the integral from 2 to 4 of little f of x. Right? Or in this case, it would be equal to 16 minus the integral from 2 to 4 of 2x dx. Now, it's usually not so nice, right? We might have something that's going to be hard to deal with, or we'll be told what the value of the integral is. It's nothing we could do by hand, and we just have to recognize certain things. But that's the idea. The second part of the fundamental theorem of calculus is dealing with, again, with the relationship between a function and its derivative. There's a function who you'll get if you integrate from, say, 1 to x squared t cubed dt. And what we want to know is, what is the derivative of x? Well, you can do this the long way. The long way would be first integrate. Well, we can integrate 3t cubed dt. When we integrate that, we would end up with 1/4 t to the 4th from 1 to x squared. And that's going to be equal to 1/4 x to the 8th minus 1/4. And then, since that's our function, its derivative must be equal to 2x to the 7th. Right? And that would be correct, and there would be nothing wrong with doing that. But what's going to happen a lot of times to test your knowledge of the fundamental theorem of calculus is it'll be something whose integral you couldn't take. So if we started over, there is some function, and what we know about it is 1 to x squared t cubed dt. and we want to know its derivative. And its derivative always has to be equal to this. If I were to substitute in x squared into t cubed, I would get x to the sixth. And if I were to multiply that by the derivative of x squared, in this case 2x, I will get 2x to the seventh. And that's always true by the second part of the fundamental theorem of calculus. Guaranteed on the AP exam there will be some problem structured like this, where this is the process they're looking for. Right, where it's a relationship between an integral and a derivative.